Hello, everyone. So in this project, I built a machine learning model to predict loan default risk using customer application data. So the goal here is to help financial institutions identify customers who might default on a loan so that they can make better lending decisions. So I will briefly go through the data preparation and code, but I will also focus on the model results and what they mean. So the target variable here is equal to 1 if the customer defaulted on the loan and 0 if they repaid it. So here I explored this distribution of the target variable, as you can see here. When we look at this bar chart, we can see that the data is pretty highly imbalanced. So about like 92% of customers repaid their loans, while only around 8% defaulted. So this imbalance is important because a model could simply predict that everyone can or will repay the loan and still achieve high accuracy. And because of this, we focus more on metrics like ROC, AUC, and recall instead of accuracy alone. Then I examine the missing values in the data set. So some variables have missing data, which is common in financial records. And so in order to kind of fix this or handle this, I used median imputation for numerical variables and most frequent value imputation for categorical variables. So this approach really allows the model to use all observations without dropping rows and really makes sure that missing values do not break the training process. So next, I created a correlation matrix to explore relationships between numerical variables. So most features are not strongly correlated, which is good because it reduces the risk of multicollinearity affecting the models. So some housing related variables show higher correlations because they describe similar characteristics of the same property, such as apartment size and or building features, for instance. So after exploring the data, I built a pre-processing pipeline. So the pipeline automatically prepares the data before training the models. So for numerical variables, I applied median imputation and standard scaling. So for categorical variables, I applied most frequent imputation and one hot encoding. So the one hot encoding converts categories like education level or occupation into numerical columns that machine learning models can understand. So next, I trained several different machine learning models that I've learned to compare their performance. So the models included the logistic regression, random forests, gradient boost, and a neural network. So testing multiple models really allows us to see which approach works best for predicting loan default risk. So when we look at the different model performance results, as you can see here, uh, yes, as you can see here. So we validated each different model like precision, recall, F1, and ROC, AUC. The best performing model here, as you can see, is uh, the gradient boosting, which achieved the ROC or AUC of about 0.79. So this metric is especially useful in this case because it really measures how well the model ranks high-risk borrowers compared to low-risk borrowers, in even when the data set is imbalanced. So next we examine the confusion matrix for the best model. The model correctly predicted 1,060 cases where customers repaid the loan and correctly identified 8 default cases. However, it missed 84 default cases, meaning those borrowers were predicted as safe, even though they defaulted. So this shows that predicting rare events like loan defaults is challenging and highlights really why metrics like recall are important in risk prediction problems. So this ROC curve also helps us evaluate the model. The curve is clearly above the diagonal line, which represents random guessing. The area under the curve, or AUC, is about approximately like 0.79, which indicates that the model has reasonably good ability to distinguish between borrowers who will repay and borrowers who may default. So I also examined the feature importance, as you can see here. So the most important features include the loan annuity amounts, the credit amounts, the goods price, credit bureau request history, income levels, and some demographic variables. So these variables make sense because they really reflect the financial situation of the borrower and really the size of the loan being requested. And finally, I performed a simple fairness check by looking at approval rates across genders. So these results show slightly different predicted approval rates between male and female applicants. This really shows or highlights the importance of really monitoring machine learning systems for potential bias, especially when they are used in financial decision making. So in conclusion, the gradient boosting model performed the best with an ROC AUC close to 0.79. This means that the model is fairly effective at ranking borrowers by risk. However, this data set is highly imbalanced, which makes predicting defaults difficult. Many defaults are still missed by the model, meaning there is still room for improvement, and yeah, overall, I think that this project really shows how machine learning can support credit risk assessment and help financial institutions make more informed lending decisions.